Hello students, welcome to Computer Interfacing course content. I am Nazmus Saqib, lecturer of BRAC University, and I will be one of the instructors of this course. This week, I will discuss about basic computer interfacing, types of interfacing, peripherals, peripheral devices, and why computer interfacing is necessary. I will suggest not to miss any points because there are some quizzes which you have to answer at the end of this video. Let's start. Let's first discuss what is computer interfacing. In computing, an interface is a shared boundary across which two or more separate components of a computer system exchange information. This exchange of information can be between softwares, can be between computer hardwares, can be between peripheral devices, humans, and can be between combination of all of this. Let me give a practical example. Just imagine when a user will switch on a computer, user will interact with a computer, where computer is a machine, right? So this can be said an interaction between a user who is a human and a machine which is a computer, right? So it is a human computer interaction and there is exchange of information between them, right? Again, let me give another example. CPU interacts with memory for reading data from memory and writing data on it. Here, CPU is a hardware component and memory is also a hardware component. And there is exchange of information between CPU and memory. So it is a hardware interaction, or we can say there is exchange of information between hardwares. Another definition of computer interfacing is that the place at which independent systems meet and act or communicate with each other. In my previous examples, user is independent, computer is independent, and where user and independent computer meets and they exchange information, right? So this is called computer interfacing. Another example is terminal network interface. Another one is parallel or serial interface. And there are a lot of examples. I will discuss them later. Let's discuss what is peripheral. A peripheral is a device that is connected to a host computer, but not part of it. It expands the host's capabilities, but does not form part of the core computer architecture. It is often, but not always, partially or completely dependent on host. Let me give a practical example. Our CPU is a large box, you know. If you don't connect power plug to its power supply port, don't connect keyboard, mouse to their respective ports, how can CPU be operated? Let's say about mouse. Mouse is connected through a port to computer. Mouse expands computer interaction with user, but this is not the core component part. We use mouse to give input to computer. User use mouse to give input to computer by pressing right or left or the wheel button, and computer performs the task accordingly. Let's say about monitor. Monitor is output device because it shows us, it displays us, or it gives us the output of the computer. That is what is going into the computer. Without monitor, projector or other output devices, CPU cannot show or display user whether user tasks are being performed or not. Three categories of peripheral devices exist based on their relationship with the computer. That is input device, output device, and input-output device. In case of input device, we can give an example of mouse. And I have mentioned a monitor, about monitor, that is an output device. And the last one is input-output device that can perform both the functionality. This is a figure of peripherals and interfaces. Here, processor and RAM are the core components of the computer. But monitor, webcam, speaker, GPU card, sound blaster card, etc. are not the essential parts. This expands CPU's both working capability and interaction capability with user. Categories of peripheral devices. Sometimes students get confused about input device and output devices. Input devices are those that send data or instruction or gives input to the computer, such as mouse, keyboard, graphics tablet, image scanner, barcode reader, game controller, digital camera, webcam, microphone, etc. Keyboard. What key is pressed, its corresponding voltage is sent as input to the CPU and CPU performs thus. Microphone. It takes audio or speech as input and gives them to CPU. Image scanner scans images and gives them as input to computer. Webcam. It takes basically the facial or environmental data or image data and send them as input to computer. So these are input devices. Output device. It provides output or gives output from the computer to the outside world or to the outside devices, to the outside users, such as computer monitor, projector, printer, headphones, and computer speaker. I have previously mentioned without monitor, CPU can't show or display what user tasks are being performed. Headphones and computer speaker give audio or speech output to the users. And the third one is both input-output device. Those perform both the functionalities of input and output, such as memory. We know CPU interacts with memory for reading data from it and writing data on it. So there is exchange of information on both way, input and output. So memory is a both input-output device. Interface and its types. A computer without any interface is completely useless and would be like a house that has no door and no window. Let's think about a computer, only a CPU box, right? But without connecting it to user or via mouse, keyboard, and monitor, what will that computer do? Nothing, right? There are many types of internal and external processor interfaces. First one is internal interface. Internal interfaces of processor are for access to internal memory, internal timers, internal comparators, or other internal resources of the processor chip, which the CPU of the processor have the access. In internal interface, CPU can access internal RAM, timers, and other internal resources through system bus and exchange information with them. Here, system bus means data bus, address bus, and control bus. Unlike external interfaces, internal interfaces have no pins. Next one is external interface. Every processor chip has pins for making electrical connections with outside. Some pins on the processor chip are reserved for providing external interfaces. Let me give an example of external interface. We all know about microprocessor 8086, which have some pins to connect external devices like programmable peripheral interface 802C55, interrupt controller, transceiver, etc. External interface can be divided into two parts. Those are external input interfaces and external output interfaces. We have discussed about mouse and keyboards, and we know they are not internal components. They are connected externally with CPU and give input to CPU. So they are external input interfaces. Other examples are pins for sensing on-off switches, temperature sensor, humidity sensor, light sensor, voltage, etc. The sensing on-off switches determine either the device will be on or off. And again, temperature sensor, it measures temperature data, which is analog, and give it as input to computer by converting it to digital data for further processing. Next one is external output interfaces. I have already discussed about monitor, which is not internal component and which is connected externally with CPU and give output to the outside world from CPU. So it is an external output interface. Other examples are controlling on-off switches, increasing or decreasing values of control devices and equipment, etc. Let me give an example. If you connect a motor by Arduino or microprocessor, you can use these processors to increase or decrease motor speed. That means exchange of information to outside devices, which will be external output interfaces. Interface can be classified into hardware and software interface. Hardware interfaces. Hardware interfaces exist in many of the components, such as various buses, storage systems, and other I/O devices, etc. Let me give an example. If there is interaction between memory and CPU, between external hard disk and CPU, between CPU and 802C55, between CPU to mouse or keyboard or monitor, etc. These all are hardware interfaces because there are exchange of information between these hardwares, right? Another one is software interface. It may refer to a wide range of different types of interface at different levels. Let me give an example of software interface. We all know when we turn on our computer, operating system is loaded. And then when we sign in, you can use different applications or softwares like Google Chrome, Music Player, PowerPoint, etc. All these applications or programs running on the operating system may need to interact via data streams, filters, and pipelines. So there exists exchange of information between softwares or application level. So these are software interfaces. Interfaces can also be classified as either serial interface or parallel interface. Then what is serial interface? In case of serial interface, it uses only one pin or one wire between transmitting and destination end, and it sends and receives data sequentially one bit at a time. Serial interface can be thought as a door to single lane highway. And in case of parallel interface, unlike serial interface, parallel interface don't use only one wire or one pin. It uses several pins or several wire between transmitting and destination end to send or receive bits simultaneously in parallel. These bits can be of 8-bit or 16-bit or 32-bit. Parallel interface can be thought as a door to multi-lane highway. I will discuss serial and parallel interface in more detail in my next video. We have already understood why computer interfacing is important. The human-machine interface determines the ultimate success or failure of many computer-based systems. Just imagine, human cannot interface our computer. Then how this world will look like. Again, without interfacing, we cannot interface digital systems to analog natural environment. We use modem in our laptop or computer. The sending modem sends data which is analog and gives it as input to computer by converting from analog to digital data. The digital data means binary 0 and 1. And when the data is processed, it is again converted from digital to analog data by digital to analog converter in receiving modems. So digital and analog interfaces are unavoidable. Basically, user interfaces is always needed in order to send instructions or to receive feedback from the computer. Otherwise, it will be a useless box of circuitry without any ability to interact with users. By interfacing, we can make using our computers much more productive and make it accessible for majority of people. Here are some typical interfacing activities. Interfacing activities help to select software hardware subsystems that can interact well with each other. I have already given example of digital to analog and analog to digital converters and also serial and parallel communication. Interfacing provides appropriate hardware connections. It helps to select cables, connectors, drivers, receivers, etc. It also resolves any hardware incompatibilities. Interfacing also helps configuring hardware interfaces correctly using low-level software drivers. Even if in embedded systems, to connect LCD keypads with Arduino or microcontrollers and to manipulate them, interfacing is needed. Interfacing also helps to interface software components correctly. It helps to select compatible software versions in the correct procedure, and it also calls the correct procedures in correct sequences. Here are some examples of interfacing. I have already mentioned about digital to analog interface of modem. Here are some related questions to this topic. Students, try to answer them correctly. The solution is also provided there. Thank you.